Welcome back everybody to another Scantime training video. This week we're going to have a look at Mitsubishi PLCs once again. We're going to be able to look at GxWorks 2. Now in previous videos we've had a look at how to create a brand new project using GxWorks 2, as well as how to create function blocks. This week what we're going to be doing is learning how to create a function inside of GxWorks 2. Now before we get started with this week's video, what I'd like you to do is hit the like button so that I know that you enjoy these videos, and also don't forget to hit the subscribe button as well so that you can stay up to date with new content that comes out every week, or most weeks when we have the time. And again, if you want to learn more about PLC programming, don't forget to visit www.scantime.co.uk and enroll on a training course today for certified training. Let's get started with this week's video. So what I've got open at the moment is GxWorks 2, and what we're going to do is we're going to create a brand new project. So what we're going to do there is just go to project, select new, and it's the FX CPU that I'm connected to. It's actually this FX2N PLC that's up there, and I've got FX2NC selected, and we're going to leave it as a structured project. So I'm not going to use a simple project, we're going to leave it as a structured project, and that there is structured ladder and FBD programming. And then all I'm going to do is just say OK. So what we're going to look at is we're going to have a look at functions. Now when we had a look at function blocks were there so that we could create a section of code to control a part of the process, and then use that section of code multiple times without us having to rewrite the section over and over again. Functions are similar in a sense, however functions are mainly there to perform a certain task, for example moving data from one location to another area, or calculating the sum of something. So for example, let's take temperature. If I've got degrees C and degrees F, and I want to convert my degrees C to degrees F, then what we could do is we could do a mathematical formula, multiply by 9, divide by 5, and then add 32 to then get to our degrees F at the end. That formula there can then be placed inside of a function so that we have a data value going into the block. It then goes through our formula and then outputs a value, and that value is degrees F, and we have degrees C coming in. And that's what we're going to do on this video. We're going to create a function to convert degrees C to degrees F. That means whenever we want to convert degrees C to degrees F, we've already now got a function designed to do that task. So let's have a look at creating a function itself. So over here where we see FB and FUN, all I want to do is I just want to right click here and select add new data. The data type is then going to be changed from function block, and it's going to be changed to function. Now what we're looking at here is the data name. Now it's best practice when creating a function inside of GxWorks 2 to give the data name the name of the result. So in our function we're going to be creating a result for degrees F. So I'm just going to call this degrees F. I'm going to leave it as structured ladder, then it's going to ask us what is the result type going to be. So I'm just going to click on the three dots, and because my result type is going to be degrees F, and we aren't going to go higher than let's say 212 degrees Fahrenheit, I can then use a word for this. If I was going to go higher than 32,767, I would need to use a double word unless we get into unsigned. But let's just leave it as a word for now, and then just say OK to that. And then here you've got use EN and ENO. This is your enable and your enable output. And what I'm going to do is I'm going to say yes to that. So I'm going to say OK, I'm going to use EN and ENO. Then just say OK. And there we go. This is our function created, and you can see it on the left hand side. Degrees F is our function that's being created. Now what I'm going to do first of all is I'm going to open up the local labels. So if I just double click local labels, this is my local label area. And if I just drop down the class window, you'll see three different types of classes. We've got a var, we've got a var constant, and then we've got a var input. Now if you can remember from our function block video, we also had a var output and a var in and out. Here we don't have that. That's because the output is the actual name of the block, which is our degrees C, and that is going to be our word. So we've only got these var inputs coming into the block, and then the internal variables inside of the block. So I know I'm going to have a var input, and I'm going to have a var input for my degrees C. And that data type is also going to be a word. Say OK to that. Right, so let's go back to our function over here, and let's just expand this network a little bit so we can see a little bit more inside of there. And what I want to do now is I want to go to my function folder, and then we're going to scroll down and we're going to grab the maths instructions that we need. So to convert degrees C to degrees F, it's multiply by 9, divide by 5, and then add 32. So I'm going to need a multiply instruction. So if we scroll down until we get to the multiplies, there it is there, mul_e. The E is for enabled. I then want the divide instruction, so that's div_e. And then I want the add instruction, which will be near the top. There we go, add_e. There we go. Place these all in line so it's a little bit neater, like so. And then all I want to do is I want to have this EN connected to the left-hand power rail, so this is constantly enabled on every scan. And then this ENO is then going to connect to this EN, and this ENO is going to connect to this EN. Think of the EN and the ENO like a short. It's like a piece of wire connecting one terminal to another, and that's all we're doing here. We're just connecting all of these terminals together so these functions will execute on every PLC scan. It's then going to ask us for our multiply inputs. So the first multiply input is going to be our degrees C. There it is there. And we're going to multiply this by 9. Now if we wanted to, we could go into our local labels and we can create a var constant for our multiply by 9 and set this to 9. But because the formula for degrees C to degrees F never changes, this is always going to be 9. So we're never going to have to change this at any point. So all I'm going to do is just type in here 9. And then it's going to ask us for an output of this. It's going to ask us for a result. It's going to ask us for the result of degrees C multiplied by 9. Now at the moment, I don't want this to be our degrees F because this isn't the end of the formula. So what we're going to do is we're going to create a temporary register. So I'm going to go back to my local labels, and I'm going to drop this menu down, select the var, and I'm just going to type in result 1. And again, that there is going to be a word. Say OK to that. And then here, just type in result 1. And then our divide is then going to take the result 1, and it's going to divide it by 5. And then we're going to store that into another variable. So we can call this one result 2. Now because I haven't created result 2, when I say enter, it's going to ask me to register this label. So it's going to register it as a local label inside of degrees F, which is what I want, and it's going to register this as a bar. The data type, I'm just going to select as a word, and then I'm just going to say apply to that, and then close that down. And there's our result 2. If it's pink, that means it's being registered inside of our program. So then take our result 2, and then add 32. There we go. And now we're going to store this in the output. Now as I mentioned before, the labels, the local labels, don't have any outputs. It's just var, var constant, and var input. This is because the name of the block, degrees F, is our output. And why I mentioned before, when you're naming your function, to make sure it's relevant to what the output of the function is going to be, in this case degrees F. So here I'm then just going to type in degrees F, and you'll notice that it's pink, which means it's been registered. And that there is the program to convert our degrees C to degrees F. So all I'm going to do now is just close down my function, say yes to that, close this local labels down. Now to add our function to our program, there's two ways we can do this. One way is we can drag it from the left hand side into our program, or we can actually scroll down our function folder on the right hand side and go to the end of D's. And there it is there, there's the end of the D functions, and there is our degrees F now sitting inside of our function window on the right hand side. So that's now available to us. So I'm going to just drag this into network 1, and you can now see there's our degrees F function, there's our enabled, and there's our enabled output. Now I want this to activate on every PLC scan, so I'm just going to tie this enabled over to the left hand power rail. I'm then going to give degrees C a data register, and we're just going to give it D100, and then the output is then going to be D200. And that's it. Whatever value is inside of D100, let's imagine it's 100, it'll then be fed into our function. It'll then be multiplied by 9, which is 900, divided by 5, which is 180, and then added with 32, which is then 212. And if you look at what 100 degrees C is in Fahrenheit, it's 212 degrees Fahrenheit. So let's test this out. What we're going to do is just save our work, and we're just going to save it as function. And then what I want to do is compile our work, rebuild all, say yes to that. There we go. No errors, no warnings, no check warnings. I'm then just going to set up the communications for our program. We're using COM2, I believe it is. So if I just scroll up until COM2 and then just do a quick connection test. Yep, successfully connected. Fantastic. Say OK to that. And now we're going to just download this to the PLC. So write to PLC, select just the program, that's all I want. 58 steps in total, and then execute that. It's then going to tell us it's going to stop the PLC, so just say yes to that. And then it's going to begin downloading. And there we go. Do we want to go back to remote run? Yes, we do. Say yes to that and close that down. And then close this window down as well. Now, if we just go online here, so just click the play button, start monitoring. Say yes. Now we are online with our PLC, and currently we can see degrees C or D100 has 0 inside of it, and our degrees F or D200 has 32 inside of it, and that there is the proper conversion. If I then just change D100 and I change this to 100 degrees C, you'll now see that jump to 212. If I change that to 50 degrees C, you'll then see that change to 122 degrees F, and that there is the function designed. Now if I just come offline here, I can then create another network. I can then copy this network and then paste this another 4 times, so I now have 5 networks converting degrees C to degrees F. If I change this one to D102, D104, D106, and then D108, and then I do the same for the outputs, D202, and then D208. That there is the program now designed for 5 different temperature readings. I can then save my work once again, compile that, rebuild all, say yes to that, and then download this back to the program. Execute that. Now 134 steps in length, say yes to that, and off we go again. Okay, knock it back into remote run, close that window, close this window, and then go back online, and then what we'll see is 5 different temperature readings coming in and 5 different temperature readings going out. Currently they're all set to 0, so if I just go to modify value, move this over here, if I change that to 10, set that, change D102 to 20, set that, change D104 to 30, set that, it goes to 86, D106, I'll set that to 40, and then finally D108, I'll then set that to 50. There we go. You'll now see 10, 20, 30, 40, 50 is now going in, and then all of our degrees Fs are then relating to the correct temperatures on the outputs, and that's the program designed. If we need to convert more temperatures, we've now got the formula to do this. We don't have to constantly rewrite that program where we multiply by 9, divide by 5, and then add 32. Now what I'm going to do here is where D100 is, I want to just modify that value. I'm going to modify it to, let's just say, 10,000. Now 10,000 is in the range of a word. A word goes up to 32,767. But watch what happens when I set it to 10,000. You'll notice that when I've set this to 10,000, we've got 4,924 degrees F, which isn't right. So why is our function now only outputting 4,924? What I want you to do is think of the answer, write the answer in the comments below, and then tune in for next week when we go over why our program has reacted like it has. For some reason our software is now bugged and we need to find out why. As I mentioned, write in the comments below why you think this has happened, and then we'll find out next week. I'll see you guys later.